Assalamu alaikum. Today we will discuss about a very important and interesting topics that how does thiazide diuretics control our blood pressure. So all of us usually know that thiazide diuretics control our blood pressure via decreasing the blood volume. How does it causes it? Because we know that in distal convoluted tubule, suppose this is distal convoluted tubules, and we know there are a transporter, it is called sodium chloride co-transporter, and thiazide diuretics block the sodium chloride co-transporter. That's why the sodium ions cannot reabsorb from the distal convoluted tubules, and more sodium is excreted through urine. That's why ultimately our blood volume decreases. Suppose this is a blood vessels, and here now the blood volume was earlier in this position, and due to excretion of more sodium and water through urine, now it is decreased, and now here. So when the blood volume decreases, that means venous return will be decreased, and venous return if decreased, then ultimately cardiac output will be decreased, and if cardiac output is decreased, that means blood pressure will also be decreased. By this mechanism, mainly thiazide diuretics control the blood pressure. That means thiazide diuretics decreases our blood pressure. But very important things that this is just for 2 to 4 weeks. 2 to 4 weeks. Why? Because when thiazide diuretics will decreases the blood volume, there will automatically activation of renin angiotensin aldosterone system. Automatically, this is a physiological mechanism. Okay, so this RAAS mechanism will try to compensate the action of thiazide diuretics. That's why it will again increases the blood volume via aldosterone. That's why thiazide diuretics will not able to decrease the blood pressure. So how does thiazide control the chronic hypertension? Because we use the thiazide diuretics for the treatment of chronic hypertension. Yes, there is a very interesting three hypothesis. We believe that thiazide diuretics actually control the chronic hypertension through these three pathway. Okay, let's see this pathway. So first of all, suppose we are within a smooth muscle cells of blood vessels. All of you know that there are three layers within a blood vessels. These are endothelial linings and smooth muscle cell layer and tunica adventitia. So we are within the smooth muscle layer of blood vessels. So this is a smooth muscle cells. Okay, and there are carbonic anhydrase enzyme. There are carbonic anhydrase enzyme within the smooth muscle cells, and this carbonic anhydrase enzyme causes carbonic acid formation from carbon dioxide and H2O. And this carbonic acid, which is formed with the help of carbonic anhydrase enzyme, is again dissociated into H plus and HCO3 minus ions. Okay, and this HCO3 minus ion, that means bicarbonate ion, will come out of the cell through exchanger transporter. That means a bicarbonate ion get lost of the cell, and H plus ion remains within the cell. And we know that if H plus ion concentration increases, that means pH within the cell will be decreases, and this decreased pH is normal, it is physiological, and this decreased pH maintains the potassium channel closed. That means when the pH within the cell is decreased, the potassium channel located on cell membrane of smooth muscle cells remain closed. That's why for more and more potassium ion cannot be come out of the cell, because the gate is closed. That's why there is a basal resting membrane potential within the cell. But thiazide diuretics inactivates this carbonic anhydrase enzyme of smooth muscle cells. That's why the carbonic anhydrase enzyme cannot form carbonic acid. And as carbonic anhydrase enzyme cannot form the carbonic acid from the carbon dioxide and H2O, that's why the carbon dioxide will easily diffuse out of the cell, because we know that carbon dioxide is a lipid soluble gas. That's why carbon dioxide is come out of the cell. That means ultimately hydrogen ion concentration is decreasing, and if hydrogen ion concentration is decreasing, that means pH will be increased, and if pH increases, that's why all of the potassium channels that were closed just before, they will start to open. That's why more and more potassium will start to efflux. They will come out of the cell. That's why there will be formation of more negative potential within inside of the cell membrane. This is called hyperpolarization. That's why my smooth muscle cells of blood vessels is now in hyperpolarized state. That's why the smooth muscle cell will not tends to cause contraction. By this mechanism, thiazide diuretics maintain our vasodilation, blood vessels relaxation, and peripheral. That means if vasodilation occurs, peripheral resistance, total peripheral resistance will be decreased because vasodilation. And if total peripheral resistance is decreased, that means blood pressure will decrease. Okay, so this is one of the hypothesis. Okay, let's see the another hypothesis. Here also we are within smooth muscle cells of blood vessels. Here you can see two smooth muscle cells. Okay, and look at the cell. Here are alpha 1 adrenergic receptors on the cell membrane of smooth muscle cells, and norepinephrine acts on the alpha 1 adrenergic receptors, and it causes activation of GQ, as alpha 1 is a GQ coupled receptor. That's why when norepinephrine binds with alpha 1 receptor, it will activate the GQ protein, and it will activate phospholipase C enzyme, and ultimately phospholipase C enzyme causes increased calcium ion concentration within the smooth muscle cells via opening of the calcium channel and release of calcium from the sarcoplasmic reticulum. Okay. Now thiazide diuretics, there is an hypothesis that thiazide diuretics causes closure of the calcium channel. That's why when norepinephrine binds with the alpha 1 receptors, and ultimately subsequently there will be activation of phospholipase C enzyme, but phospholipase C enzyme will not able to increase the intracellular calcium concentration because the thiazide diuretics already closes the all of the calcium channel located on the cell membrane and also the smooth endoplasmic reticulum. Okay, so this is one of the mechanism, and another one is, look at the flow chart. That means when phospholipase C causes increased intracellular calcium concentration within the smooth muscle cells, this increased calcium causes the formation of calcium calmodulin complex, and this calcium calmodulin complex will activate the myosin light chain kinase enzyme. This calcium calmodulin complex will activate the myosin light chain kinase enzyme, and this myosin light chain kinase enzyme then causes phosphorylation of myosin protein. That's why there will be actin myosin coupling, because myosin is now activated, and if actin myosin coupling occurs, then there will definitely be smooth muscle contraction, and that means vasoconstriction occurs. Okay, so normally our blood vessels remains within a basal vasoconstriction to maintain the vasomotor tone. It is normal, but so there are also, Almighty has created already within the smooth muscle cells another enzyme. This is called myosin light chain phosphatase, and this enzyme tries to inhibit the myosin light chain kinase. So think about that, such concentration. That means myosin light chain kinase tries to cause vasoconstriction, and myosin light chain phosphatase tries to inhibit the myosin light chain kinase and tries to do vasodilation, but we need vasoconstriction state to maintain our circulatory status. So Almighty has created another pathway. This is called RHO/RHOA pathway. This pathway inhibits the myosin light chain phosphatase. That's why it cannot inhibit the myosin light chain kinase. That's why myosin light chain kinase easily can do its purpose, and myosin light chain kinase usually maintain the vasomotor tone. Now come to the point. Our thiazide diuretics inhibit this RHOA pathway. That's why RHA pathway is suppressed, because thiazide diuretics suppressed it. That's why RHO/RHO pathway cannot inhibit now the myosin light chain phosphatase. Cannot inhibit. So myosin light chain phosphatase is now more and more activated, because there are no one who can suppress the myosin light chain phosphatase. That's why myosin light chain phosphatase will now more and more inactivate the myosin light chain kinase. That's why myosin light chain kinase now suppressed by myosin light chain phosphatase. And now this, or as myosin light chain kinase is decreased within the cell or inactivated, that's why all of these steps will not be happened. That's why vasoconstriction cannot be occurred. That means indirectly there will be vasodilation. Okay, and we know that if vasodilation occurs, that means total peripheral resistance will be decreased, and if total peripheral resistance is decreased, that means blood pressure will be decreased. So thiazide diuretics actually decreases our chronic or maintain our chronic hypertension via these three pathways. Okay, in this pathway thiazide diuretics inhibit the RHOA pathway, and via this there is increased activation of myosin light chain phosphatase, and this increased activation of myosin light chain phosphatase will decreases or suppresses the myosin light chain kinase enzyme. That's why myosin light chain kinase cannot maintain the vasoconstriction. That's why there will be vasodilation, and it will leads to decreased total peripheral resistance. Ultimately our blood pressure will be decreases, and it will reaches a basal normal level. That by this mechanism thiazide diuretics controls our chronic hypertension. Thank you.